Now we've got lab number 2, falling objects. So now our system is, in my case, the ball, and we've got to analyze the interaction between the system and the surroundings. We've got that there are going to be two forces acting on our ball. The first is the weight. The weight is the mass times the gravity force, and it's always in the opposite direction than in the negative direction of the y-axis. So now we also have a drag force. In this case is a turbulent drag force, which is negative b times the velocity vector, and we have chosen b equals to the magnitude of the velocity squared. So our final drag force is going to be the negative velocity magnitude squared times the velocity vector. Now, if we want to get the net force acting on the system, it's going to be the sum of the weight and the drag force. For example, if we look at our ball, we're going to see that there is a weight force acting downward in the direction and a drag force, a turbulent drag force, more specifically acting in upward direction. Now, if we look at our Python model, we'll see that we've chosen the weight formula, the drag force formula, writing here before what is our B. Now, while t is greater less than 0.417, it's in our values. We've got here gravity value, and if we run it, we get this. I'll try again. So it's that the ball start a little bit to the right on the acceleration. If we look at vertically, we'll see that it goes straightly downward, and if we look at the graph, it will be a parabola with the x-squared coefficient less than 1. Now, if we look at our experimental values, I've chosen the ball's diameter, which is 0.2 meters, and our axis, that here's the positive x direction and the positive y direction. So if we play it, we'll see the ball accelerating downward, and we've got some values that we have analyzed it here on Excel, and we get that there is on pink there is the experimental values, whether in blue there are the theoretical values that we get on Python, and maybe these deviations from the theoretical movement of the ball will be caused because there is more drag than we have supposed. There is a more surface of the ball wherever the air can exert a stronger force there that we have supposed. Now we can say, what if we chose, for example, a initial velocity greater than 1. So here we can see that if we throw the ball downward faster, for example 0.25 meters, it will be the ball will go faster than we have supposed. Sorry if you didn't see great. I have some problems with VIDLE, but you can see that the ball started to move faster than before. So that's all. Lab number 2, falling objects.